Hello and welcome to the channel. What does 81 to the power 3 over 4 mean? And how do you solve 81 over 16 all to the power minus 3 over 4? In this video we will first discuss the laws of indices or powers with examples, and then we will tackle some questions like these. Let's start with the three basic rules first. Any number to the power 0 is equal to 1. So a to the 0 is 1. The number a is called the base and it is raised to the index or power 0. The next one is that any number a to the power 1 is simply equal to itself. So a to the 1 is a. Lastly, 1 to any power n is equal to 1 because 1 is unique as all operations with itself lead to the number 1. For example, 1 times 1 times 1 etc. equals 1. 1 divided by 1 equals 1. Any root of 1 is equal to 1, etc. A negative power is simply the reciprocal of the positive power term. So a to the minus n is equal to 1 over a to the positive n. Take an example. 10 to the minus 2 is equal to 1 over 10 to the 2, or 1 over 100. In order to multiply bases, we just simply add the powers. So a to the m times a to the n is equal to a to the m plus n. For example, 10 to the 1 times 10 to the 2 equals 10 to the 3, or 1,000. Or expressed in another way, 10 times 100 equals 1,000. We can see in this example why the powers add up, as we are simply adding zeros to get the final value. Let's take another example. 10 to the 1 times 10 to the minus 1 equals 10 to the 0, which is equal to 1. We can see why this is by expressing it differently. 10 to the 1 is 10, 10 to the minus 1 is 1 over 10. Multiplying the two simply leads to 1. This is another way of saying that a number multiplied by its reciprocal is by definition equal to 1. This explains why any base to the power 0 is equal to 1. Let's take another example with different bases. A times b cubed times a squared times b. Here we have to apply the rules separately to each base. So in this case we add the powers separately, which leads to the answer of a cubed times b to the 4. In order to divide bases, we simply subtract the powers. So a to the m divided by a to the n is equal to a to the m minus n. For example, 10 to the 3 divided by 10 to the 1 equals 10 to the 2, or in other words, 1,000 divided by 10 equals 100. When we have mixed bases, we apply the rule separately. So a cubed times b to the 4 divided by a squared times b is equal to a times b cubed. If we wish to raise a term containing a power to another power, then we simply multiply the powers. Thus a to the m raised to the power n is equal to a to the m times n. Let's take an example. 10 to the 2 raised to the power 3 means 10 to the 2 cubed. This is simply 10 to the power 2 times 3, or 6. This can also be visualized as 10 to the 2 times 10 to the 2 times 10 to the 2 equals 10 to the 6. We are effectively using the addition rule here because the term in the bracket has been multiplied by itself 3 times, i.e. 2 plus 2 plus 2 equals 6. Which is equivalent to using 2 times 3 in the original expression. As before, when using different bases, the rules apply separately. For example, the expression 2 times a squared times b cubed has 3 bases, a, b and 2. When we cube this, we cube each base, and this leads to 2 cubed, or 8, times a to the 6 times b to the 9. Let's now move on to fractional powers. A base a to the power 1 over n is simply the nth root of a. For example, 100 to the half is the square root of 100, which is 10. 27 to the 1/3 is the cube root of 27, which is 3. So what's 27 to the minus 1/3? Well, it's just 1 over 27 to the positive 1/3, as we discussed earlier, which is simply 1 over the cube root of 27, or 1 over 3. Let's now have a look at this expression. The cube root of 3 multiplied by itself 3 times. This is by definition equal to 3. This can also be expressed as n to the 1/3 multiplied by itself 3 times, which is simply n to the 1/3 plus 1/3 plus 1/3, or n to the 1 by the addition rule. We can see now why a to the power 1 is equal to a. Let's now move on to two-stage fractional powers. Any base a to the power m divided by n is equivalent to a to the 1 over n, all raised to the power m, which is the same as the nth root of a, all raised to the power m. An example should make this easier to follow. Take 9 to the 3 over 2. The 3 over 2 is a result of two indices being multiplied by each other, i.e. a half times 3 equals 3 over 2. And so 9 to the 3 over 2 is equal to 9 to the half, all cubed. This is simply the square root of 9 cubed, or 3 cubed, which is 27. Take another example. 1,000 to the 2 over 3. This is the same as 1,000 to the 3rd, all squared, or the cube root of 1,000 squared, which is 10 squared, or 100. It's possible to express two-stage fractional powers with the process reversed. In the last example, we could have expressed it as the cube root of 1,000 squared, which would still give the same answer of 100. However, it's usually much easier to use the method described here, which is to take the root first and then raise it, as this can be done much more easily without a calculator. Now let's look at some worked examples. 81 to the 3 over 4 is equal to 81 to the quarter, all cubed, or the 4th root of 81 cubed, which is simply 3 cubed, or 27. 125 to the minus 2 over 3. Let's take the reciprocal and change the sign. Thus 125 to the minus 2 over 3 is equal to 1 over 125 to the positive 2 over 3. And we can just proceed to simplify the denominator to 125 to the 1/3 all squared, which is the cube root of 125 squared, which is 5 squared, or 25. So the final answer is 1 over 25. 81 over 16, all to the minus 3 over 4. Again, first take the reciprocal and change the sign. So the expression becomes 16 over 81 to the 3 over 4. This is the 4th root of 16 over 81, all cubed. Because we now have two different numbers or bases, we have to apply the rules to each one separately. The 4th root of 16 is 2, and the 4th root of 81 is 3. And so the expression simplifies to 2 over 3, all cubed. Once again, there are two bases here, and we have to cube each one. So the final answer is 8 over 27. The last question is, given that 1000 over the cube root of 10 equals 10 to the power x, find the value of x. To solve this, we just have to simplify the left-hand expression into the form of 10 to the x, and the value of x will become self-evident. 1000 divided by the cube root of 10 can be expressed in a number of different ways, as 10 to the 3 divided by 10 to the 1/3, or 10 to the 3 times 1 over 10 to the 3rd, or 10 to the 3 times 10 to the minus 1/3. If we take the first form, then we subtract the indices because of the division, and if we take the last term, we add the indices because of the multiplication. Either way, we are left with an answer of 10 to the 8 over 3, hence x is 8 over 3. I would advise any young student to practice indices and become very fluent in them, as they're a fundamental tool in maths. If you like this video, then please subscribe to watch more like these. I will see you in the next one.